Prop Stat students, Mr. Mitchell here. Today we're going to take a look at random variables and finding mean and standard deviation of those. So let's go ahead and get started. So we're in chapter 6, section 1, random variables and probability distributions. All right, we're going to talk about what a random variable is. So it's a quantitative variable that assumes a value determined by chance or a random outcome. All right, so talking about things that are number-based, quantitative, not qualitative variables. So it's got to be something that has a numeric value to it and also has a chance of it happening. Okay, so we have continuous random variables. All right, it's a quantitative variable that can take on any number of countless values. All right, the amount of rainfall in your state during the month of June. Example of that could be in Carlisle, we could get 12.2 inches of rain. In 2 miles down the road, they could get 11.78 inches of rain. So there's an indefinite amount of rainfall that you could get, and it could fluctuate even in one city by, just minuscule amounts, but it's a continuous thing. All right. Another example would be time in terms of if I get a better stopwatch, like we can measure time in centuries, decades, in years, in months. So how good of a measuring tool do I have? Okay, days, hours, minutes, seconds, milliseconds. So how good of a watch do we have? That's continuous. If I get a better watch, I can break it down further. Okay, so that's kind of the idea. That's continuous. Discrete is a quantitative variable. Takes any finite number of values or a countable number of values. Number of books in a library. Another way to think of it is you can't, for discrete, you don't usually have parts of things. It's either a book or it's not. Like you might say, well, that book has been destroyed and it's no longer a book. Well, then it's trash. We don't count it as a book anymore. If it's a book, then we count it as a book. All right. So just like same thing with people, it's a person or it's not. If it's a child, they're still a person. If somebody's passed away, then we probably don't count them as a person anymore, right? So it just depends on the scenario. But discrete is something you can count, and you can't have other things in between. When you roll a die, when you 1, 2, 3, 4, 5, or 6, you can't get a 5.5 when you roll a die. It's not possible. It's not one of the outcomes. So that's discrete. Okay, for stuff that you can get everything in between certain numbers, that's a continuous random variable. So you just need to be aware, because we're going to do different calculations. What we're going to talk about in this chapter are more discrete. In the next chapter, in chapter 7, we're going to can focus on continuous random variables. So we're identifying them now, but we're really going to focus on discrete random variables, and then we'll come back to continuous later. Okay. Probability distribution is an assignment of probabilities to those specific values that can happen. So when you roll a die, you can get 1, 2, 3, 4, 5, or 6. The probability distribution is 1/6 for each of those outcomes. They are the same across the board. That doesn't have to be true. We're going to look at an example today that they're not going to be the same from one thing to the next. Okay. Some things that we just need to be aware of when we're looking at probabilities with a random variable. The sum of the probabilities must be equal to 1. So you can't have it be bigger than 1. The cliche in athletics, give 110%. That works for trying to motivate people and things like that. But in terms of probability, you can't give more than 100, more than 1. It's not possible. Okay. And you can't have negative probabilities, which this kind of alludes to. You can't have negative probabilities. The worst you can do is 0. Like, what's the probability that I'm at home right now? Well, it's 0. I'm in school at my classroom. There's no chance of me being at home at this instant. Okay. What's the probability that I'm in school right now? It's 1. It can't be greater than 1, but it's a guarantee. I'm sitting in my room right now. So that's the idea. And the probability has to be somewhere in between there. You might say, well, what's the probability that you're in your class tomorrow at such and such a time? Well, depending on what time it is, it could be very high or very low, but it's not a guarantee because it's tomorrow and you don't know. Maybe I'm not in my classroom at a specific time. Or if you say, well, 4 o'clock, it's probably very unlikely that I would be, but I could be. So it just depends on the scenario, but it's somewhere between 0 and 1, including 0 and 1. All right, so here's some formulas. We're going to do one thing one time by hand, and then we're going to use our calculator to figure it out because technology can help us. It's more about being able to interpret and identify what needs to be done, not necessarily the long drawn out formula method of calculating everything. But this is finding the mean or expected value, mean and expected value, what should happen in the long run. And then there's your standard deviation. Again, they don't look very friendly and they're not too bad. Okay, but we're going to practice them both by hand and with the calculator. So let's take a look at our example. So North Carolina State University posts the grade distributions for its courses online. Students in Statistics 101 in a recent semester received 26% A's, 42% B's, 20% C's, 10% D's, and 2% F's. Choose a statistic 101 student at random. The student's grade on a 4-point scale is a discrete random variable. So once you've, like, I know our grades, you can get a whole bunch of different percents, but once it's been identified a letter grade, it's that letter grade. Okay, I know our scale, we have pluses and minuses, but even that, you're still locked into that letter grade. You can't have anything in between there. Okay, so these are discrete. You can't get a 3.3 for one class. Now, maybe if you average multiple classes together, that's different. But for this class, you're getting 0, 1, 2, 3, or 4, and that's it. All right, and these are the chances. Notice they are not equally likely. It's not like rolling a die and everything is the same. You're more likely to get a B than a 0, an F. Okay, so we're going to find the mean, and then we're going to find the standard deviation, and then we'll do it with a calculator. So to find the mean, bear with me a second, I gotta pull up my slideshow so I can write. So to find the mean of the random variable X, we're going to take each outcome times its probability. I don't know why I did that. So my first outcome is 0, take it times its probability, plus the outcome 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 times its probability. So you're taking each value times the chance that it happens, and then you're adding all those up. It's not like finding a mean where you did before, maybe this year or in some other class where you add them all up and divide by how many there are. You do that when everybody is equal, everybody is the same, or all the grades are the same. But you are very unlikely to get an F, much more likely to get a B. So B carries more weight than an F. So that's why we have to multiply them by their probabilities. Okay, so now we're going to go to our calculator. And we're going to take 0 times 0.02 plus 1 times its probability, which is 0.1, plus 2 times its probability of 0.2, plus 3 times its probability, which is 0.42, and then plus 4 times its probability, 0.26. So we have each outcome times its probability. Uh-oh. I forgot to close off that parenthesis. Oops. Should not be 0. I got to insert. That's okay. There we go. I knew it wasn't 0. So the average or the expected grade in this class is a 2.8. Okay. So we expect to get a 2.8. Can you actually get a 2.8? No, that's the average. So if you took many, many, many students and find the average grade, it's going to be a 2.8. So it's roughly almost a B. Okay. So if you just add up 0, 1, 2, 3, 4 and divide by 5, it's not going to be 2.8. All right. It's going to be a 2 if you add them all up and divide by 5. So because 0, 1, 2, 3, and 4, assuming they're all equal, 2 is in the middle. So that is not the case. That's not how you find mean of expected of random variables for expected value, because you have to deal with the weight. 3 is more important than 0. 4 is the next more important grade, and then 2, then 1, then 0. All right. So now we're going to find our standard deviation. Okay. And so if I go back, here's my standard deviation formula. So let's interpret this. We're going to have to take a big square root. We're going to have to take each outcome minus the mean. We square that, and then we take it times its probability. Okay. So again, we're going to do this one time and then probably never do it again. And that's okay. You can still do it if you like. So we're going to take a big square root. I'll hold off on the square root. I'm actually going to call this finding the variance first, since I don't want to write a big square root. So we're going to take our first outcome, which is 0, minus the mean, and then we square that, and then we take that times its probability. Okay, so let's recap what just happened. I took my outcome minus my mean, I square that, and then I take it times its probability, which was that. And then I'm just going to repeat that process. So now you take your outcome minus the mean, you square that, and then you take it times its probability. All right, and then you keep repeating until you have no more outcomes left. So then the next outcome is 2 minus the mean, square that, take it times its probability. And again, I'm not sure why my pen acts goofy sometimes, but it does. So now we have done 1, 2, 3 outcomes. Now we're on to the next one, the 3. So now we're going to take 3 minus the mean. We're going to square that. We're going to take it times its probability. And then we're going to take the last outcome, 4 minus the mean, square it times its probability. Okay, so whatever answer we get there, that's going to be my variance, and then I'll square root that and get my standard deviation. So let's go to our calculator. So we're going to type this all in at once using all our numbers. We're not going to do it piece by piece because that's just a recipe for disaster. So let's take our outcome minus the mean, square it times its probability. So there's the outcome was 0, the mean, square it times its probability, plus the next outcome. Notice I'm using parentheses. Have to use parentheses or it's not going to be correct. Times its probability, plus the next outcome, 2 minus the mean, square it times its probability, plus the next outcome minus the mean, square it times its probability. And then one more, you have the last outcome, 4 minus the mean, square it times its probability was what, 0.26? I think I gotta double check that. Yeah, it was 0.26. Okay. So my variance is 1. When I square root that, my standard deviation will be 1. So when I go, don't forget so we found our variance to be 1. And then I do need to take the square root of that number. The square root of 1 is just 1. So that's not always going to happen where the variance and standard deviation are the same thing. Just so happened that the variance was 1. Okay, so don't forget to take the square root. So now I found my mean and my standard deviation. This is how I would do it by hand. Okay, most of you are not going to choose to do it this way. The mean's not too bad. Standard deviation can be quite a mess. All right, so let's go to the calculator. All right, so what I did here, you could do with any regular calculator, but the part I'm going to show you now is something special for a TI-84 or something that's more advanced. So we're going to type in our data. So we go to stat, just like we typed in any other data that we've done before, whether it was 2 variables or 1. You go to stat, edit, and in your list 1, you're going to type in your outcomes. So your outcomes are 0, 1, 2, 3, and 4. Those are the grades that you can get. Those are the outcomes. In L2, you're going to type in the probabilities that those outcomes could occur. Now, notice they have to match up with each other. You just can't type them in anywhere you want to. 0, this is its probability. 1, there, that's probability. 2, 3, and 4. They have to match up. So L1 is the outcomes. L2 are the probabilities, the frequencies. Okay. Once you do that, you go back to stat, go to calc, and you're going to do 1-bar stats. List is the outcomes that you need to type in. So tell it, it's L1, that's where we typed it. And then frequency list, you don't have to use frequency list when you're just doing it for when everybody is the same. Like if we didn't have probabilities here, then there wouldn't be a frequency list. But we do have probabilities here, so I have to tell it L2. And then I'm going to calculate that. So there you can see, there's my mean, 2.8. And then there's my standard deviation of 1. A lot easier to do it that way. But again, you have to know how to use the calculator correctly. You can't blame it on the calculator. The calculator is always right with what you tell it. All right. So that's your mean and standard deviation concept of random variables. All right. Let me know if you have any questions.